Okay, so coming on to question number 13, we have to find the shortest distance between these lines, and this is the line 1, this is the line 2, and we have the Cartesian equations of the lines. So these are the Cartesian equations of the line, and we know that the Cartesian equation of a line is x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. So let's consider this as a1, b1, c1. So these are two equations. So these are x minus x2 is equal to y minus y2 is equal to z minus z2. It's z2, and okay, so it's x minus x1 upon a2 is equal to y minus y2 upon b2 is equal to z minus z2 upon c2. So this is a line 2 and this is a line 1. And if we compare the line 1 with this standard equation, it gives us that x1 is minus 1 and y1 is minus 1 and z1 is again minus 1. And a1 is 7, b1 is minus 6 and c1 is 1. And similarly, if we compare this line 2 with the standard equation, this gives x2 is 3, x it's y2, so y2 is 5 and z2 is 7, and the direction ratios a2 is 1, b2 is minus 2 and c2 is 1. And because we have to find the shortest distance between these lines, and these are the Cartesian forms, so the shortest distance between the lines in the Cartesian form is given by x2 minus x1 and y2 minus y1, z2 minus z1. It's a1, b1, c1, a2, b2, c2. We have to find the determinant for this. And this whole value has to be divided by, uh, how do I remember it? So because these are the direction ratios A, B, C. So I will write BC first. So it's BC minus BC. Then it's AC. So I will write CA minus CA. And then it's AB. So it's AB minus AB. And just give them 1 and 2. It's 1, 2, 1, 2, 1, 2, 1, 2, and 1. So this is B1 C2 minus B1 C2. Okay, it should be 1 2 2 1. Okay, let me just write it once again. So how do I remember it? It's A B C. So the first one is BC. So I will write BC minus BC, and then it's CA. So I will write CA, and then it's AB. So I will write AB and AB. So it's B1 2 2 1 1 2 2 1 1 2 2 1. So it's A2, it's actually A2 B1, and put in the negative sign between them, give them, add them, square them, and under root them. So that's how remember the formula. And this is the shortest distance. So if I put in the values, this gives me x2 minus x1 is 3 minus of minus 1 is 4, and y minus of minus 1 is 6, 5 minus of minus 1 is 6, 7 minus of minus 1 is 8, and it's a1 b1 c1. So 7 minus 6 1, and 1 minus 2 1. It's 1 minus 2 1. So we have to find the det for this. And regarding the value, that's this. So our b1 is minus 6 and c2 is 1 minus, b2 is minus 2 and c1 is 1. So that is the whole square plus c1. is 1, and A1, A2 is 1. So it's C1 is 1, A2 is 1, it's A2, and minus C2. C2 is 1. So let me just confirm it once again. C1 is 1, and A2 is 1, C2 is 1, A1 is 7, the whole square, plus A1 is 7, B2 is minus 2, this is minus 2, minus, so it's A1 B2 and A2 B1. A2 is 1 and B1 is minus 6. So whole square, and it all has to be in the root. Okay, so let's try to evaluate this. So this is the shortest between these two lines. This will give us the shortest distance. So the first one, let me just find this that along this row. So it's 4 into hide the row and the column for 4, it's minus 6 minus of minus 2. Then it's negative 6 and 7 minus 1 plus 8. It's minus 14 minus of minus 6 is plus 6. So under root it's minus 6 and plus 2 the whole square plus 1 minus 7 is minus 6 the whole square, and it's minus 14 plus 6 the whole square, the whole under root. Let's try to simplify this. 4 into minus 6 plus 2 is minus 4. It's minus 6 into 6 plus 8 into minus 8. And this should be minus 6 plus 2 is minus 4 square is 16. It's 36. Minus 14 plus 6 is a minus 8 square is 64. And now this should be equal to minus 16 minus 36 minus 64. Whole under root is 16, 36. It's 12 and 52, 64 is 6 and 116. So it's 116. This should be 64 plus 36 is 100, is minus 116 by under root 16. So this gives us, and this should be the positive. The distance is positive, so it's has to be the positive value. And let me just put it like this. Okay. Okay. So this is 100 root 16 by 116 minus root 16. That gives me 116. If we rationalize this, and this is 116 into 100 root 16 by 116. So that gives me under root 116 square units. And if we rationalize this, this can be written as 258, 229. That should be 2 under root 29. It's not square units, it's the unit. That should be 2 under root 29 units. So that's the distance. And that's the answer for question number is 13 for exercise 11.2. And let's check if it is the correct one. Yes, it is. All right, so that works for question number 13. Thank you for watching.